Let's look real quick at number 130I, where we're using the root test. And we have a series n equals 0 to infinity. This is 3 to the n divided by 7 to the n. Sorry, that's a little sloppy. 7 to the n, all raised to the nth power. In fact, if you think about it, another way you could have written this 3 to the n and then raised to the n power. Remember, we multiply power, so this is like 3 to the n squared over 7 to the n squared. Or you can even write this as 3/7 to the n squared. So I mean, this form could have been written in different ways, is all I'm saying. But here's the root test. We take the limit as n goes to infinity of the nth root of the absolute value of the a sub n. So I'm going to use this right here as my a sub n. And so when I plug it in, there it is. And we got the absolute value, but notice, 3 to the n, 7 to the n, raised to the n, going to infinity power, they're always positive. There's no negative value, so we can just get rid of the absolute value bars. So of course, the whole reason the root test works so nicely here is we've got to the nth power, the nth root to the nth power. This is 1 over n power. This is n power. When we multiply those exponents, n times 1 over n, we get 1. And so they cancel each other out in this effect, right? And we're just left with this. So a lot of people have a little trouble with this. They start thinking about maybe the fact that this is infinity over infinity form, and let's use L'Hopital's rule and get somewhere. Not going to work. Okay. What you realize, again, like I said up above, 3 to the n divided by 7, that is the same as 3/7 raised to the nth power. Right, so it's the same thing. And here, this is a geometric sequence, right? The sequence 3/7 to the nth, and we're finding the limit of the sequence, right? It's 3/7 and then 3/7 squared and then cubed and so on. What's this sequence approaching? What's it approaching? What's the limit as n goes to infinity? Well, it's geometric with r equal to 3/7. Since the absolute value of r is less than 1, what's that mean? The limit is 0. All right, 3/7 to higher and higher powers is getting smaller. It's getting closer to 0. It's approaching 0. And so you've got to remember the geometric sequence. Okay, we got geometric series, we got geometric sequences, and there's a difference there. They're connected, obviously, related, but you have to remember geometric sequences and the fact that they will have a limit of 0 if the value of r is less than 1 in absolute value. So the limit is 0. And the root test says if this limit is less than 1, then the series is absolutely convergent. If it's greater than 1, then the series diverges. If it's equal to 1, then the test is inconclusive. Well, since we get 0, that's clearly less than 1. By the root test, we know our series is convergent. Okay, so I hope this helps with this one. So you've got to remember, a little bit about finding limits of sequences in applying both the root test and the ratio test.